Good afternoon, everyone. My name is Tim Yeager, and I manage the vertical markets and municipality practice at Tarana Wireless. We're going to give a couple more minutes for people to hop on, and then we'll get started. So probably about 2 minutes past the hour, we'll get started. Thank you. Good afternoon, everyone. My name is Tim Yeager. I manage the vertical markets for Tarana Wireless and municipal practice. Today, we're going to talk a little bit about the next generation of fixed wireless access and how they're being deployed in municipal networks. If you have any questions, please type it into the question box, and we will start to address these at the end of the presentation. Thank you very much. So today, we're going to cover some of the requirements of municipal networks, along with who is Tarana Wireless, what makes us different from traditional fixed wireless radios, how Tarana is addressing the requirements of municipal networks, a brief roadmap, examples of deployments, and how to engage Tarana. This is not an all-encompassing list of all the requirements for municipal networks, but what it is a list of requirements that we're seeing common among all different types of municipal networks out there. So the first one is reliability, and that goes hand in hand with durability. Resources within the municipal environment, you do not have a huge staff to maintain these wireless networks, and every one of these outages can cost money. It definitely cost money, but some of them will actually cost hard cost money due to SLAs, and that also goes down to durabilities. Cities and municipal deployments cannot afford to be replacing radios very frequently, every 2-3 years. They need to be able to last a long time. They also need to be able to work in harsh conditions. Everybody always quotes lab numbers and everything like that. And what we've been drilled into our head is it doesn't really matter what the numbers look like in a lab environment. These are in real world conditions, and the environmental conditions, whether it be a water wastewater facility or maybe a trash area, they're not necessarily the best conditions for wireless. Ease of deployment. Again, the municipalities have limited number of resources out there, so you have to be able to deploy these radios easily and manage them remotely. You don't want to have to be dispatching technicians to determine what the problem is. You want to dispatch a technician to fix an issue on there. And some of these networks could be dozens of miles away from where they're being monitored. So you need to make sure that they can be monitored remotely and managed remotely as well. Increased demand for data. Many factors roll into this, whether it be on a SCADA side, you're monitoring your network far more often than what you used to, where you used to get information once an hour, once a day. You're now getting it every 5 seconds and then publishing it every 5 minutes on there. You're deploying more applications in your network to monitor and manage your network. You're deploying video. Video takes an immense amount of data. So these are factors that are starting to demand more data usage and bandwidth within these networks. Upload speed. By managing these networks remotely, you greatly increase the need for upload. And the reason for that is you're getting the data from the network that you're having to make decisions on. And if you cannot get that data in a timely manner, your decisions are greatly impacted by what data you have. So again, with these being industrial type networks and mission critical networks, you need to be able to get as much information as you can from a remote site at any given time. And lastly, security. Security goes without saying, but you definitely need to make sure that the information on these networks and traveling over these networks meet the security requirements for that municipality. Who is Tarana? We are a fiber class fixed wireless broadband radio manufacturer. We're based out of Milpitas, California, and we qualify for the Made in America designation. We're over 14 years old and have invested more than $300 million in R&D over that period of time. Well over 28 patents and still more pending. Our current offering includes 5 gigahertz versions, 3 gigahertz versions, and when the standards are ratified by the FCC, we will be rolling out a 6 gigahertz version. G1 is the name of our product now. It doesn't stand for Generation 1, it stands for Gigabit 1, and we have designed this from the silicon up. So we are not repurposing chips from other types of radio deployments. We are using something that is designed specifically for fixed wireless access. We started shipping general availability of our product in October 2021, and we've grown to well over 200 full functioning deployments, not counting pilots, over the little over a year and a half. So 95% of the fixed wireless access out there uses either the 3GPP chipset or the Wi-Fi chipset. The 3GPP chipset is the same chipset that is run in your cell phone. So there's a lot of buzz out there right now about 802.11ax and 6 gigahertz product. Again, as in most times when people are talking about stuff, there has been some miscommunication out there. 802.11ax is a standard where 6 gigahertz is part of a spectrum. They are being used interchangeably, but what we can do is address the 802.11ax standard and then talk about 6 gigahertz as well as part of a spectrum. So Wi-Fi 802.11ax still has the same design parameters. It is designed so you can use it as a network communication with your computers and other communication devices within your house. It has simple beamforming, usually at the AP or the access point only. It is not an adaptive MIMO. It lacks support for near line of sight and non-line of sight deployments. And again, I'm talking much more on the fixed wireless side than what it is as an indoor access point. This spectrum that it's used in is uniband 1 and uniband 2. They're very congested. Uniband 3, which is part of the 6 gigahertz deployment in uniband 5 and uniband 7, already are occupied by incumbents. They have no interference, immunity, or mitigation to them. But the biggest drawback that we are seeing is the overhead can account for up to 40% of the bandwidth. And every person that is added onto that access point cuts the bandwidth that everybody gets. So for example, one person is on an access point, they're getting 100% of that bandwidth. 2 people jump on, now it's 50%. 3 people, it's now 33%. So the performance drops very dramatically, very quickly. So again, we're talking 802.11ax. The biggest factor that we're seeing in 802.11ax for them to hit the bandwidth that they are promoting with this product, you need a single 160 megahertz wide band channel to operate in. They just don't exist out here in the real world right now. With our existing product, we only use 80 megahertz of the spectrum, and that can be broken up into 2 40 megahertz section of the spectrum. And what I've done on this slide is shown various business cases and deployment types out there, and we are no different than any other radio technology. Physics does still impact our performance. So as you can see, our performance does go down from 2.4 gigabits per second per sector down to 1.8 with the various use cases that are out there. But with 802.11ax, you're showing a dramatic drop from 1.5 gigabits per second estimated down to 114. And these are all based on real world type of deployments that are out there. 3GPP or mobile is not the answer either. Again, the 3GPP chipset is the chipset that's in your phone. It relies on a licensed spectrum. There is minimal interference rejection out there. The bandwidth that comes on using this technology comes from the tower, and that's where the beamforming happens with this. It does not have asymmetrical signal strength. Perfect example of this is we've all sat in venues or stadiums. According to the phone, we have 5 bars of signal on there, but yet we can't make a call or we can't send a text. And the reason is we can hear the tower, but the tower can't hear us. So the signal strength, upload and download, is completely different. It also uses 2 parts of the spectrum. So for example, if you have 90-degree sectors, north and south would use one part of the spectrum, and east and west would use another part of the spectrum. And lastly, limited capacity. We saw the difference in the capacity in the previous slide. In best case, 1.5 gigahertz to what we're doing at 2.4. But again, you're starting to have much smaller sectors and be able to support much less performance on these networks. So Tarana is currently offered again in a 5 gigahertz frequency, which is unlicensed, and the CBRS spectrum again at 3 gigahertz. We have the ability to cancel, not mitigate, but literally cancel up to 45 dB of self-interference and 40 dB of interference from other radios. Keeping in mind 3 dB doubles the signal strength every time you add 3 dB to something. Cooperative bidirectional beamforming. So we can beamform on both ends of the link, and we do that at 5,000 times per second. And again, our signal strength from both the download from the tower to the remote node and from the remote node to the tower is the same performance. So again, you can be deployed in high density areas and still be able to get your signal back up to the tower. And we use spectrum reuse of 1. So where 3GPP has to use 2 parts of the spectrum in a 360-degree deployment, we only have to use 1 part of that spectrum. And that gives us scalability over other types of fixed wireless access that's out there. Again, it doesn't really matter how the radios perform in a lab. What really matters is how they perform in the real world. And in the real world, you have obstructions, you have interference or noise floors, you have throughput and capacity issues. Link reliability is a big piece on there. Channel congestion is a big piece on there. So again, Tarana works in near and non-line of sight deployments by utilizing reflection and multipathing, and with computing power on both ends of the link, we can realign the signal to make it a usable signal. That gives us more reliability, more throughput, and longer distance. Again, we have interference cancellation. So in a noisy environment, it is like trying to talk to somebody at a loud party. You have to scream, you can't hear that well. But with our interference cancellation, it is like having a one-to-one conversation with someone. We have high throughput and spectral efficiency. So each one of our remote nodes can handle up to 800 megabits per second of bandwidth. With that, we'll address what's coming in later this year. But again, with our spectral efficiency of being able to use the same parts of the spectrum in all 360 degrees of a deployment, what that allows us to do is to expand and use more radios out there in different parts of that spectrum. So why Tarana? So our minimum deployments that we want to deploy is at 100 megabits per second. It's fiber class speeds, and we can go up to a gigabit later this year per RN. Low latency and long range. So our standard profile is 15 kilometers, and we have a long distance profile that lasts up to 31 kilometers. High capacity per sector. On traditional fixed wireless, you're looking 40 to 60 remote nodes per sector on there. Whereas with Tarana, we can support up to 250 nodes per sector. Solid connections despite real world obstacles, whether it's trees, buildings, vehicles moving in and out. With us using multipathing and reflection, we're able to overcome these obstacles to provide a reliable throughput for these deployments. What this allows us to do by doing non-line of sight and near line of sight, we can reduce the need for vertical assets. So we reduce the need of total vertical base node towers out there. Consistent, reliable throughput. All the customers really want is a good, reliable network that meets their communication needs. If you can't deliver a reliable, stable network, it kind of defeats the purpose of deploying out a broadband. Again, we have unlicensed and licensed options for you. Our remote nodes are simple to install. You literally point them towards the tower where the base node is, and they will self-align. I equate it very similar to either a DirecTV or a dish network type of deployment. Our computing power on both the remote nodes and the base nodes allows us to have unmatched performance out there by realigning signals and making whatever adjustments we need to with the beamforming as well. We can cover more locations per sector because we have the ability to do near line of sight and non-line of sight deployments. Simple roadmap. Things to keep in mind here is later this year, we're going to be releasing higher performing remote nodes, which will give us up to 1.6 gigabits of throughput, so true gig capabilities. And whether it is an existing remote node now or one that you buy in the future, you'll be able to upgrade those via firmware from 5 gigahertz to support 5 and 6 gigahertz on there. Our base nodes, we will be releasing a 6 gigahertz version of the base node, and then also upping the throughput per sector of those as well. When we do the upgrades and move to offer a 6 gigahertz product, we will be expanding out the channel size that we're using from 80 megahertz to 160 megahertz. But again, it does not have to be one big chunk of the channel altogether. You can break that up into 4 40 megahertz parts of that channel. Where are we deploying in the municipal market space? So we are augmenting fiber in a lot of these spaces, whether it be hitting 20 or 30 buildings that's off a major fiber run that it doesn't make sense either economically or in the time to deploy fiber. So we are, again, augmenting the fiber, use the assets that you already have deployed with that. Video surveillance. There are a great deal of video surveillance is starting to be deployed out for safety reasons, whether it be facial recognition cameras, license plate recognition cameras, or just plain security cameras out there. With that, you're having a very much increase in demand on bandwidth of the network out there. And if you want to deploy video, again, you need the upload speed that Tarana offers to be able to make that a reliable connection that can work with your video. Public Works. We have a city that was looking at upgrading the irrigation control of one of their parks for their sprinkler system. They were looking at industrial radios that cost about $1,800 a piece. We were able to provide bandwidth to all of those sites, whereas the industrial radio was offering a 4 megabit of throughput. We were able to get well over 200 megs download and more than 100 meg upload on those exact same locations. Now the city can deploy Wi-Fi in the park using that network and also provide video surveillance in that park as well. And on top of that, you have extra bandwidth when more applications start to be deployed along this city network. Traffic is a big use of data networks right now within the cities, whether it's traffic flow, you're trying to control certain areas of traffic to reduce congestion, or you need to know how many cars are turning left at a certain intersection, or is the bike lane being used? What does the pedestrian traffic look like? Bike traffic, pets, are they there? Which way are they going? What is their behavior? All these analytics are being deployed in the city networks on the traffic side. Worked with one city that wanted to deploy a radar solution along with a camera solution in the downtown area of their city to get just what I was saying, those analytics. And problem was the conduit for fiber in the downtown area was full. So they had to either take the time, money, and inconvenience to run additional fiber or more fiber, or they had to deploy fixed wireless access. Traditional fixed wireless access was not going to be able to suit their needs due to the non-line of sight that you have from buildings, trees, and other obstacles in a downtown area. Plus, you had a very large noise environment down there from Wi-Fi hotspots and Wi-Fi within the buildings to wireless ISPs providing bandwidth down there. So deploying Tarana for this network, we were able to hit the non-line of sight locations and also provide noise cancellation, so they were able to get a reliable network to run their video feeds for their traffic. And again, municipalities are deploying the next gen fixed wireless access in the public works environments where they need to get a higher bandwidth to assets where they used to not need that. Water is now considered critical infrastructure along with electricity. So now video surveillance is starting to be deployed in all of those. So traditional SCADA networks are being overloaded with the demand for data that is being required to run those networks. Traffic infrastructure, whether it's smart metering for meters on the road, on the traffic, for parking meters, or it is working with the traffic department to control the flow of traffic on an on-ramp or off-ramp of an interstate, so you don't have traffic back up onto the interstate or into the intersections getting onto the interstate. And public safety, whether it be video surveillance or letting the public safety know what's going on in a remote location, so when they dispatch either the officers or fire department are not walking into an unknown situation, where they can actually deploy and know what is going on there. They're also providing a foundation for smart small business incubators. We are starting to see cities tout the fact that they have high-speed access in areas to promote small businesses into those areas so they can meet their needs. And you're never fully going to future-proof a network, but what this does is it allows cities to deploy a network that has a longer shelf life or can be added on in multiple ways compared to what they were able to do before. And they can do it in an economical manner as well. So again, if you have questions, please feel free to type up your questions into the question and we'll start to answer those. And from this is my contact information on here, and also the engineer that I work with with, but please feel free to reach out to your Winncom sales team, and they can track us down pretty much wherever we are. And we're more than willing to help talk about your networks and see what we can do. Let me see if we've got any questions here right now. We got a couple. The first question is, on the 5, when we release the 6 gigahertz product, will that be backwards compatible with the 5 gigahertz product? On the remote side, you can upgrade traditional remote nodes via firmware to be able to support the new deployments on there. You are going to need different base hardware to support those networks as well. The other one, on municipal networks that are being deployed, who owns the infrastructure? We're seeing it both ways. We are seeing public-private partnerships where the city may own a network and they are having it managed by a managed service provider, or an ISP has entered into an agreement with the city to provide the infrastructure for the city. And a lot of these are being deployed to help satisfy the digital inclusion aspect out there. And with that, the managed service provider is starting to take a much more active role with that. Last question I got here is, how does this interact with existing municipal networks? So in municipalities, I've seen many SCADA networks on there. I've seen communication networks for data going back and forth. This is kind of a hybrid of the situation. You can run the SCADA network over the Tarana in a point-to-multipoint fashion, as long as you have it converted to Ethernet traffic as well. But we are starting to see some cities also deploy this as an overarching infrastructure and allowing multiple departments to access that network, and each having their own VLAN, so there is some privacy of data with that as well. So are there any other questions that anybody else has? Okay, give it a second here to see if people are typing in. And then again, please reach out to your Winncom sales folks. They'd be more than happy to work with us and you to help you to design and come up with the right solution for your network. Okay, I don't see any other questions coming in. But again, if you have questions that you think of after, please again reach out to Winncom and they'll get it to us and we will be more than happy to answer them. So thank you very much, and everybody have a good afternoon.